Okay, number 3 tells us that a temperature is at most -2 degrees. So that means the most it can be is -2. So I always like to draw these number lines when I'm thinking about negative numbers, just to think about what is happening. So here's -2, and this is the highest that it can be. So it's pretty cold. So that's the most it can be. So we're looking at anything smaller than -2. So if it's over here on the positive side or even -1, that is not going to be part of our solution. So let's see which of these are true. So numbers less than 2, right? So we want less than 2 are part of the solution. Numbers greater than 2 are not, right? Because this says at most it's -2. So if it said the least it could be is -2, then we would want everything that's bigger. But yet we don't want greater numbers. We want the smaller ones. At most means that's the biggest it can be. So -2 is part of the solution. So it can be, right? It tells us the highest it can be is exactly -2. So I would say that yes, -2 is part of the solution. But as soon as we cross that line into 1.99, then that's not a solution. So would 0 be included? So we're looking at anything in this direction is good, this direction is not, and 0's in the opposite direction as bigger. So 0 is not part of the solution. -17 would be over here somewhere, right? If we kept on going, -3, -4, 5, 6. So yes, -17 is part of the solution. So I want you to think about 17 over here. Would 17 be part of this solution here? So now we're going to finish this inequality. So T is our temperature, and it said at most it could be -2. So the highest it can be is -2. So we want all of our temperatures to be less than or equal to -2. So I know it can be really tricky. Sometimes I want to say, oh, I want 2 to be smaller, but I didn't want 2 to be the smallest thing. I wanted my temperatures to be less than 2. So always think back to your inequality. Does this make sense? My temperature is less than or equal to -2. So let's go ahead and make a solution set of 3 temperatures that T could be that are -2 or smaller. So always ask yourself, can it be -2? And in this case, yes, it can, because we have this equal sign here. So it could be exactly -2. So I want you to see if you can think of 2 other solutions it could be. I'm going to choose -5 and -9. This is not a very good graph for this, but that's okay. So we're going to say here's -2, here's -5, here's -9. And now I'm going to graph -2. So come back to your inequality. So I'm going to circle -2, but the garage door shut. So we need to close the garage door, which means to close in this circle here. There we go. And then I connect all of my possible solutions. So this shows me the temperature can be -2 or anything smaller than that. So part B tells us that Raphael needs to buy more than 4 concert tickets, more than 4. So we want to think about how many tickets can he buy. So let's think about some things that are true. Numbers. So we want our T tickets to be more than 4. So it doesn't say 4 or more, it says more than 4. So numbers less than 4 would be part of this solution. I don't want less than 4, I want more than 4. numbers greater than 4 are part of the solution. That sounds good. Can he buy exactly 4 tickets and meet his needs? He needs to buy more than 4. If he only buys 4, he's going to have some sad friends. So 4 is not part of our answer. Does he want to buy 0 tickets? No. Does he want to buy negative 17 tickets? No. Could he buy 17? Yes, 17 is greater than 4. So our inequality was that we wanted to buy more than 4. We want our ticket number to be greater than 4. So go ahead and see if you can create a solution set here for t is greater than 4. So can it equal 4? No. Then he's going to, so 4 is not greater than 4. So I could say he could buy 5 tickets, he could buy 7 tickets, he could buy 9 tickets, and that would all be greater than 4. So I'm going to quickly mark those on my number line. So now I want to graph my inequality. So I circle my 4, and the garage door is open. It's not closed here at the bottom. So it's open, so I leave my garage open. And then I connect all of my possible solutions to say that t cannot equal 4, but it can be any amount bigger than 4. So go ahead and complete task 3 and do your check for understanding. And if you have any other questions about this or need help with your lesson, then be sure to let me know and we can set up a time to meet. So remember, we're going to keep practicing these, but just remember, can it be bigger or smaller? And then pay attention. Can it equal that thing? Is the garage door shut? Fill in your circle. Is your garage door open? Leave your circle open. Hey, good luck.